In this lesson, we learn what is precipitation reaction and how to write the equations for any particular precipitation reaction and how to know that which salt solution will form precipitate or not. So first of all, we need to know the concept of precipitation. Let's have a look at this solution. This is solution A. When I say solution, I mean solution in water. And solution in water mean the solute is dissolved completely and the solution is clear and see-through. For example, if you take a glass of water and you add 1 spoon of salt or 1 spoon of sugar in water and you mix it properly, now that is called a solution. So water is solvent and the salt or sugar you added is solute. Together they make a solution, and a solution is always clear. You can't see any solid particles in it. So let's imagine that this is certain solution A, and it is in one test tube, and we take another solution B. So basically, solution A has certain solute or salt dissolved in water, and then we take another test tube, and other salt is dissolved in water. So there are two different salt solutions. Now we pour solution A into solution B. So what will happen that the volume of the solution will be double, like because two liquids are mixing. But at the same time, we will see that something which is not soluble, something undissolved is formed, and that was not already there. That solid is coming out of the solution. So basically, when they were not mixed, both salt were in dissolved form, but when we mix them, one of the salt becomes undissolved. Now, this solid, which is formed by mixing two clear see-through solutions, called precipitate. And this reaction is called precipitation reaction. All right. So the solid which is formed, which is called precipitate, was not already there. That came out of the mixing of two solutions. All right. So if you take another glass of water and you try to dissolve something, it doesn't dissolve, it just settles down. That is not a precipitate. Precipitate always comes from two solutions. When you mix them, then you get a solid form that's called precipitate. Now, these are different examples of precipitations, right? Like when you're mixing solutions, um, different salts which are becoming precipitate will look different. Some are white, some are green, some are, the dark, some yellow. So they are different solutions. So in this lesson, we will learn that how different equations form solution, and those solutions, when they are mixed, how they form precipitate. So let's see first example. Imagine that we have a solution which is AgNO3. Now, AgNO3 is a solution. Whenever some solution is in water, we always write small aq with that as a subscript. So this aq mean aqueous, and aqueous mean AgNO3 is added in water and it is fully dissolved. This solution is see-through and clear. So we have this first solution. Now, take another solution now, sodium chloride. This is normal kitchen salt. So this is also dissolved in water. So I write AQ with it. Now we mix these two solutions. So when we mix these two solutions, this arrow shows the direction of what's happening now. So when we mix two solutions, what all we need to do is swap the cations and anions. So this Ag will go with Cl and this Na will go with this. And write on the other side of the equation, write the new formulas. So when Ag goes with Cl, it becomes AgCl, and sodium becomes sodium nitrate. All right. So we have two new salts on the other side of the equation. But how do we know that which one is precipitate and which one is still in the solution? So remember, there's a rule, we call it SNAPE rule, SNAPE. All right. So each letter is the starting point of some ion. So sodium nitrate, ammonium, potassium, and ethanoate. So if these ions are present in any salt, that salt is always dissolved in water. All right. So you may have two, or you may have only one of these SNAP ions present, but even if one is present, that salt will dissolve in water. All right. So in this case, because sodium nitrate, the sodium and nitrate both are in the SNAP rule, so we say that this is AQ. And if this is AQ, then this must be the precipitate or solid. So this is one way of writing the precipitation reaction. So start with solution A, another solution B. You mix these two solution, and then you form two new salts. And those two new salts, one could be solid form. The solid one is called precipitate. So basically, this is precipitate. All right. And the aqueous one is in the solution, so that's not precipitate. So this is one example of a precipitation reaction. Let's see a few more examples. Now, in the second example, we take copper sulfate, and copper sulfate is solution in water, so we will write AQ with that. So copper sulfate, because this is dissolved in water, we write AQ with it. And then we take another solution, sodium hydroxide, so NaOH. This is also solution, so we write AQ with it. On the other side of the equation, all you need to do is swap the ions. So copper goes with OH and sodium will go with sulfate. But before you write the formula on the other side, you need to apply the rules of writing ionic formulas, because sodium is +1. Remember, sodium is +1 when it is going with sulfate. So sulfate is 2 minus. So crisscross method, this 2 goes there and this 1 goes there. It becomes Na2SO4. So we need to make sure that we follow these formulas. So when sodium reacts with sulfate, it becomes Na2SO4, and copper and OH. Again, copper is 2 plus and OH is minus. So this 2 goes there outside the bracket, and this one comes here. So it becomes copper hydroxide 2. All right. So we need to write this CuO. All right. So now this is on the left side of the equation, both are solutions. So we wrote AQ. Now on the right side, we have sodium sulfate and copper hydroxide. Again, because sodium is one of the ions of SNAP rule, the first one as sodium. So this is AQ. And this one is the precipitate. Copper hydroxide is the precipitate. But do you see that the balance is not equation is not balanced, because sodium here too. There are two sodiums present. There is one sodium, so I write 2 here to make sure that it is balanced. Now it is balanced. So this equation is called the full equation or net equation. Now, other than full equation, sometimes you're required to write ionic equation. So what does ionic equation means? It means that write the equation with only the ions which are making precipitate. Now, the precipitate is this one, all right? So what two ions are making that? So first we write the precipitate, CuOH2, and this is precipitate. So what two ions are making that? We know that. The copper, 2 plus, and OH, there are two of those present. So these two R's in the aqueous medium, they are making the precipitate. So this is called ionic equation. So when you write full equation, this is called full equation or net equation. In the full equation, you write all the solutions, all the precipitate, everything. But in the ionic equation, you just pull out the precipitate and write the two ions which are making the precipitate, and it should be balanced. Now, the ions which you did not write in the ionic equation, for example, you did not write sulfate, you did not write um, sodium, all right? Those ions which you did not write in the ionic equation, which are not part of the ionic equation, they are called spectator ions. So spectator ions for these reactions are sulfate and sodium. These are the ions which we did not write in the ionic equation. Any ions which we are not writing in the ionic equation are called spectator ions. Why we call them spectator ions? Because they are just there in the reaction to balance all the cation, but they are not making the precipitate. They are just there as spectators. They are not doing the actual job of making precipitate. All right. So this way of writing is called ionic equation. We see one more example, then I hope you'll fully understand this precipitation concept. The next example is sodium sulfate. So I'll write sodium sulfate as sulfate is 2 minus and sodium is +1. So we use the crisscross method. So sodium sulfate would be Na2SO4. All right. So this is sodium sulfate. Because it is solution, I'll write AQ with it. And strontium chloride is Sr. Because Sr is 2 plus, so I need to write Cl2 again AQ. Now we swap the ions. So this sodium, it goes with chloride, and strontium goes with sulfate. All right. So we write sodium chloride plus strontium sulfate SrSO4. Now, how do we know that which one is AQ? Because sodium, it is following the Snape rule, SNAPE. So first one is sodium. So this is AQ. And strontium sulfate is the solid or precipitate. All right. Is this balanced? Not yet, because on this side we have 2 chloride and here we have 1. So maybe we write 2 here. That makes sodium 2 and chloride 2. And here sodium 2 and chloride 2 all balanced. So this is called full equation. Now we want to write the ionic equation. So like I told you before, ionic equation is the two ions which are making precipitate. So first I want to do is what? I want to write the arrow first and then the precipitate. Because my precipitate is this, I'll just write here Sr, SO4, and solid. So this is my precipitate. What are the two ions which are making this? The strontium and sulfate. So I'll write strontium with the 2 plus and sulfate with 2 minus. 2 minus. This is 4. And both are AQ. All right. So that is the ionic equation. Now, what are the spectator ions? Any ions which are present in the full equation but not present in the ionic equation. So strontium sulfate are present, but sodium is not present and chloride is not present. So I'll write spectator ions are sodium and chloride. They are my spectator ions. All right. So I hope you understood this. If you watch this video before watching the ionic naming, then it might be confusing for you. So I want you to first watch those videos and then come back to this. I hope you understood this. And if not, please watch this video again. And thank you. All right.